Okay, so let's talk about different ways to identify acids and bases. We've already talked about, in the two previous videos, we talked about the 5 characteristics of acids and 5 characteristics of bases. So we know that based on the ions that are formed when you put an acid or a base in water, we could tell if it's an acid or a base. We know that if we tasted it and it tasted sour, we could tell that it was an acid. Or if we tasted a substance and it tasted bitter, that it was a base. We know that bases have a slippery feel. But we also know that acids and bases can be very dangerous to the touch and also to the taste. So there are other ways to determine if something is an acid or a base. So our objectives today, watching this video, we have 2 objectives. The first objective is to use something called the pH scale to determine if a substance is an acid or a base. So we'll talk about the pH scale, and then our second objective will be to explain how indicators are used to identify acids and bases. So why is it that you can eat lemons, but you can't eat something like battery acid? The reason is because some acids are stronger than others. That's the same with bases. Some bases are stronger than others. Some acids and some bases are more corrosive and they react more with metal. Sometimes we think of acids as really, really strong and really, really dangerous, and that's true. But that's only for the very, very strong acids. And there is a level of strength to them. And we use something called a pH scale to determine how strong an acid is or how strong a base is. So here's a pH scale. You can see it goes from 0 to 14. Number 7 here in the middle represents neutral. What happened here? Let's fix that. Come on. Okay, so something that's neutral, an example would be distilled water. Something that's neutral is not an acid or a base. It's neither one. But if you move, on this scale, if you move farther to the left, it becomes stronger and stronger and stronger acid. So the pH for an acid is between 0 to 6.9. Where 0 would be very, very strong and 6.9 would be very, 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 very weak, almost not an acid at all. Now on this scale, if you move over to the right, you can see that something is a base. Here they call it alkaline. Alkaline just means basic or a base. Okay, so as you move away from the 7 in the other direction towards the 14, you're becoming a stronger and stronger and stronger base. It's becoming more corrosive and more dangerous. So the pH for a base is between 7.1 to 14. And there are lots of different varieties of pH scales. Here's an example of one you can see that's up and down where the 0 is at the top. So the acids are at the top and the bases would be at the bottom. And you can see examples of really, really strong acids. We've got battery acid, hydrofluoric acid, hydrochloric acid that's in your stomach, and then we have some really, really weak acids, the saliva in your mouth, urine or pee-pee, and coffee, soda, those would be weak acids. Here we have pH 7, again this is neutral. So it's not an acid or a base. That means, for example, pure water, if I put water in water, it's not going to form ions, it's going to just be water. And as we go down, it becomes more and more basic, more dangerous. Seawater, slightly alkaline or basic, baking soda, going all the way down to liquid drain cleaner, which would be very, very dangerous. If you use liquid drain cleaner too often, you can actually destroy the pipes in your home. Here's another example of a pH scale. This one's a little different. You can see that the 0 or the acids are on the bottom and the bases are on the top. Okay, still some examples here. And over here on the left, we have some numbers. This is concentration of hydrogen ions compared to distilled water. And so remember when we talked about acids and when we put those in water and they break down and the hydrogen ions break off and then join with the water molecules to form hydronium ions. Well, pH stands for potential for hydrogen. And what it means is how likely is this substance going to form hydronium ions because that hydrogen ion breaks off. And you can see here that with a pH of 7, it's not likely at all. It's 0 likeliness. And as you get closer and closer to 0, you have a very, very high likelihood that it's going to form ions. And as you get farther and farther and farther away, it's actually the opposite or the inverse of hydrogen ions. It's forming hydronium ions. And so the bigger the number, either in the numerator or the denominator, is going to make a stronger substance. Okay, and we have one more pH scale. I like this one because it has the pictures. It's a picture scale, so you can see that drain cleaner is a very strong base, ammonia is a strong base, and an acid would be a weak base. Over here we have battery acid would be a strong base. Apple juice would be kind of in the middle, and here we have coffee would be a weak acid. Okay, so based on the pH scale, we can tell if something's an acid or a base, and we can tell the strength. So how do we know what the pH is? Well, we can use something called indicators. And what indicators are is they're chemicals or substances that can change color when they're mixed with acids or bases. And the easiest way to look at it is something called litmus paper. And litmus paper is just a strip of paper that's been treated with one of these indicator chemicals. And so up here we have a little strip of paper that's being dipped in a liquid, and you can see that the paper that's coming out of the liquid is red. And so because it's red, we know that this liquid is an acid, because litmus paper turns paper red, turns red when it's in the presence of an acid. And down here we have a piece of litmus paper that's turned blue in this liquid, and we know it must be a base because litmus paper turns blue in the presence of a base. So that's one way to tell if it's an acid or a base, using these things called indicators. Specifically, this litmus paper is treated with an indicator that changes either blue or red. There are different types of indicators and there are different types of litmus paper. I'll show you another example. Sometimes you can see litmus paper comes in these tubes, and if you've ever gone to a swimming pool and seen how they can change the pH of the water, they put the chemicals in the water. Well, they're going to test the chemicals according to a color scheme. And you can see that this is also litmus paper right here, and based on the fact that it's on this lemon and the lemon is turned red, well, here's the key on this diagram here, and you can see that based on the color that it turns, you can see the relative pH, if it's a strong acid, a weak acid, or if it's a base. In this case, lemon is a citrus fruit, so it has citric acid in it, so it's going to be an acid. And so if we could see the small teeny tiny print on this bottle, we would be able to see that this red color indicates it's an acid. Okay, but not all indicators are put onto strips. Sometimes you can use indicators that are liquids, and you drop them into the substance and then they will change color. And here are some examples of different types of indicators. We've got methyl orange, methyl red, bromothiamyl blue. Here's our litmus that we talked about. We've got red and blue. Remember, if it's a base, it's going to turn blue. If it's an acid, it's going to turn red. We have something called phenolphthalein and indigo carmine. Now, not all of these are very good at determining whether it's an acid or a base. You can see this methyl orange. It only turns red if it's a very, very strong acid. And this indigo carmine on the bottom, it only turns yellow if it's a very, very, very strong base. So those might not be very good indicators to use all of the time. But this one right here, phenolphthalein, it only changes color to pink if it's a base. And bromothiamyl blue will either be yellow or blue based on if it's an acid or base. So some of these indicators are really good ways to figure out if something's an acid or a base. If you wanted to see if it was a strong acid, maybe you would use methyl orange. If you wanted to see if it was a strong base, maybe you would use indigo carmine. But if you didn't care about the strength, if you just wanted to know, hey, is it an acid or a base, you could use these litmus, bromothiamyl blue, or even phenolphthalein, and maybe the methyl red.